This is the FalconsAI DTT SimBench, a chip physics test range for thermal management intelligence. Before testing, a look inside. The layers spine in execution order, modules stacked above their children, amber lines tracing data flow. Back to the console. 4 modes on the left, 6 scenario batteries, and 8 sliders that shape the ordeal. Duration, workload stress, interference, sensor corruption, cooling health, core count. But today isn't one test. This is the production capability checklist. 13 items run in order. A calm baseline, all 6 battery sweeps, an escalation ladder, randomized soaks, a second seed confirmation, a sparsity audit, and a deployment package. Qualification, not a screenshot. First, the baseline, a healthy, quiet die. Watch the heat map stay cool and violet. This step exists because the first industry-grade question isn't can it fight fires, it's can it leave a healthy chip alone. Every run also executes a hidden twin, the identical scenario with the model disabled. Protection is only ever the measured difference between the two. Now, the sustained load sweep, the die warms and the gauges tell the story. Peak and mean close together means load is being spread, not piling onto one core. Below, the temperature trace and per-tick recognition accuracy draw live. The composite lands, and the qualification table starts filling in. Each finished step banks its score, its seed, and its gate results. Some rows already carry the green qualifying badge. That means all 8 gates cleared, not just a pretty composite. Cooling degradation now, the scenario where the heat sink slowly fails. Recognition dips when events inject, then recovers within ticks. Dips are fine, it's the recovery that's graded. The checklist keeps its own honest ledger. 5 steps green, each with composite and gate count. Sensor aging next, the model must read a die through lying thermometers. Power virus migration, the cruelest battery. A worst-case load hunts across the die. Watch the peak gauge. The model's job is to keep that number from running away from the mean. Every readout explains itself. Click the info dot and the bench tells you in plain language what recognition per tick means and why the dips matter. The escalation ladder. Same scenario, rising stress, until something gives. This step grades gracefully degrading behavior, and it's scored at a threshold that admits the ordeal is designed to hurt. 2 randomizer soaks. Scenarios the model has never seen, drawn blind. No curriculum to memorize, just physics and judgment. The score holds. And the step that separates evidence from luck, the best qualifying run replayed on a different seed. Same configuration, new dice. If the result was real, it survives. The full ladder, top to bottom, 13 rows, scores, seeds, gate counts. And then the banner. Production ready. Every gate cleared on a calibrated run, and the sparsity audit beneath it is the quiet headline, 98% fabric quiescence. The Guardian sleeps through most ticks and stays mostly silent even when awake, protection that costs almost nothing. The full trace is banked, and the guide's last instruction is printed right on the banner. Clear it once more on a different seed before shipping. One export row now holds everything. The evidence pack with every seed and twin comparison, the complete failure and pass history, forge-ready training fuel, and the deployment package with integration scaffolds for both major neuromorphic ecosystems. And for everything else, the built-in FAQ. Every dial, readout, and button on this screen, explained in plain language, searchable by category. That's the bench. Physics as the examiner, twins as the ruler, and a verdict you can hand to a skeptic. Prove the model against the physics. Find out more at FalconsAI.